Hello everyone, this is Jason Sikes, aka the Tech Rancher. This is my solution for homework lesson number 12. The lesson is from Paul McWhorter. He does several different types of courses, and this course is the one with the Raspberry Pi Pico W. Understanding Controlling RGB LEDs. Check him out. I really learned a lot from Paul, and you should go check him out. Alright. Hey everyone, how you doing? I hope you're having a good weekend. Let's see, let's get started here with what we got so far. Let me get to my circuit diagram. Where did it run off to? Here we go. Well, let me explain a little bit first before we really get too much diving into this. Paul asked us to do a homework assignment. He wants us to take user input, turn on the RGB, and use the colors either red, green, blue, cyan, orange, yellow, orange, and white. The user can choose any one of those colors, and we're supposed to be able to display it on the LED. This is going to require some math. I did mine a little bit different than probably what some other people might have done. I went ahead and went with the color values, the 16-bit color values that you can find on the internet. Same thing you do with if you do any kind of web coding. You're going to use the R and then G and B, red, green, and blue, and you're going to combine them to get to that color that you want. That's the same thing I did. First, before we get really into the math, let's go look and see how I set my circuit here. Now, as you can see here, I got my Raspberry Pi, and I'm running off of pin 13 here, running it to the red. Alright, pin 14 running for green, and pin 15 running for blue, and these are actually coming over here to the actual correct pins to the RGB, running through a 330 ohm resistor, and I got my ground connected to here to a pin number 33, I think that's what it'd be. 38. See, I got two more left to get to 40. Yep. Alright, now since we saw how it's laid out, let's dive in here to a little bit of the code. Well, wait, once again, here's how I did my schematic diagram. Got 3.3 volts coming in, well, using a USB connection. And then, as I said, you got 13, 14, and 15 coming out, red. Then we go to green and blue, coming right through here and connecting to the ground. Pretty simple, straightforward. Now let's go over here and look at the code. I'll step through the first part, and then we'll get into the math. We imported our library machine and the classes of PWM and PIN and ADC, which I do not know. Oh, correction. I was trying something else. We don't really need the ADC. That was another little project that I was trying, and I'll do that. I'll show that on. Actually, Paul actually asked for the same thing I was going to do on lesson number 13, and I was already going to do it on lesson number 12 to be a little bit fancy. But let's go ahead and stick with what Paul wanted here on 12 first. So I don't need the ADC. So then I called in time. That's the library time, and the class is sleep. Then I called in. I put all my colors into an array for several different reasons. But first, because I liked it contained, and I like to be able to iterate it through it when I'm printing it off for the users to be able to choose from. So I stuck them in an array. Then I broke them down into. This is where I was talking about red, green, and blue that you can choose from, and that's what I did here. And I put them in an array also in actual order of red, green, and blue. And that's how come they're in here like this. We will actually call on those integers to be able to access those, 0 through 2, 0, 1, and 2. I'll get into more on that when we get farther down in here. Then I went ahead and set my time. And then down here we're calling our pins to be able to start getting us going. I have red pin, which is 13, as I was talking about in the schematics. And then green pin 14, blue pin 15. Then we create our objects, red LED, and I gave it the frequency of 5,000. I actually did an experiment with that, and I never did see a difference when I went down from 1,000 up to 5,000. But I just thought, well, the higher frequency, the more it's going to be bright, and you're not going to be able to see any flickering at all. So I just went ahead and went with 5,000. I don't know why, I just did. And then get the duty unsigned 16 to 0, so we got it off, is what we're saying. Assign the green object and a blue object, all the same thing. And then I called a function, and this is where I added in my math, the function calls. I just kind of liked it cleaner. I want it to be recallable, and just went ahead and decided to do with the function. See, I was going to do the math on a write out. Let me see here what I got real quick here. Hold on here. Let me drag this over here and see what we can do. And let's zoom in on this. I think about 150 out of work. And let's get down. This is just like almost everything else that Paul has had us do in the past. For me to be able to get 255 to 65,535, we're going to have to take, we're going to grab it off of a point slope and be able to use that to convert that over. And Paul had taught this many times to us. And we're going to start with a slope. But to get a slope, you have to start getting with a line. And we already know 0 to 0 is our first point. And our next point would be 255, 65, 535. If you take those 2 points and you run it together, you get a line. And now we need to be able to choose any number off that line to convert it over for our math to convert 255 to 65,535. Went ahead and did that. Went ahead and did from delta y over delta x to get my m, which is our slope. We have a slope of 65,535 over 255, y over x. And then went ahead and converted it over to our point slope intercept. This is the point slope intercept formula that I did. And I have it labeled as color brightness equals 65,535 over 255 times user color input. The color that we did for an array also is what I'm saying here. So that means I'm going to have to do an array color point for the red, green, and blue. Each one of those for the math to be able to convert that over. That's kind of more what I described down here, what I did in my notes, but I just said it. So let's go to the code. Let's minimize this. Here we are back into the code and to the functions. I'm going to kind of step through the functions here. For those who've never really done functions in Python, I'll go over just a small amount, but there's multiple tutorials online that you can be able to find out. So I'm not going to go too in depth, but I'm just going to go in a little bit that you might be able to understand. Okay, to do the function, you define it by define, def, because we're defining a function. Then we're going to give it a name. You have to give it a name that would somewhat describe what that function is or does. And so mine is red color brightness. Because if the user types in red, and I'm going to call, okay, realize that the user calls red, and then I'm going to call that function. And then I'm going to have to add in some arguments. Arguments also, you have to have a unique name to go with that. And you need a name that would describe what you're wanting the argument to do inside the function. So I have R underscore LED, and then green RG underscore LED, and B underscore LED. That's pretty self-explanatory. I'm bringing in the red LED object, the green LED object, and the blue LED object. And so down here we're setting up a variable called R brightness, and that's going to have our math into it. And so our point slope intercept is going to be labeled as R brightness for the red. And in here I'm running in and putting in my array. And we're using it, oh, my one's totally went blank. Where that value is stored at. The integer, there you go, the integer, we're saying we're wanting 0. We're wanting the value, but it's located in 0, which is, and for red is 255. So we're taking the point slope times 255. And that's stored into the variable. And then it's the same thing with the green and the blue, and then down here we'll go for the red, and we're going to take that math that we did and then put it into the duty underscore unassigned 16. And so now we're saying, hey, use that math that we just did and illuminate the RGB. Pretty simple. So I went ahead and did a function for every color that Paul wanted us to do. Then now we get down to the heart, the loop. I did a try and accept. Keyboard interrupt would actually kill it. So here, while true, as Paul always says, true is always true. True is going to continue to go until it's false, but it's always going to be true. Sorry. Color choice. This is what I named my variable for asking the user what they want. And so then I wrote my F string in here and said, what color would you like the RGB LED to display? And then here's where I ran in to iterate the array. I don't know if very many of you know how you can do that, but subtract the double quote that usually a list or an array will do is I'm specifying to put inside of there a comma in between each of the objects, or not objects, it'd be items inside that array, and then I'm putting a comma and then adding join to that, and it's going to iterate through all of that because I'm telling it to iterate through the color of array. So then I went through an if statement and said, well, okay, then I stored it into a variable and lowercase everything, and that's one way how I can do a verification check that they had added in a color, instead of doing it capital and then having to make sure that if someone wrote lowercase r and a capital E and then a lowercase d, it wouldn't throw an error. I just went ahead and said take everything and make it lowercase. And so then I took that and I'm saying if lower color, which is that variable that we had just established here, equals red, and it's all lowercase, so I'm saying because it's what it's going to do, it's going to end up being lowercase. And I said if it does equal red, then then call that function that we just described about red color brightness, and then I added in the arguments of red LED, green LED, and blue LED, and then took those and had it run through the function, and that's how it works. And I'm going to switch to a camera real quick. Oops, go over here. I still haven't got this down pat, moving all these cameras around. Hey, there we go. There it is. Now let's start this real quick. I'm going to clear this bottom that you can see down here, and then start that clear, and we're going to, well, I forgot to even stop it. Now we're going to run it. What color? Let's go through these colors here real quick. Let's go through red. There's red being shown. Let me show off these overhead lights. There we go. Oh, much better, much better. Okay, there's red that you can see. Now it's asking us for other color. We're going to go do green. Oops. See, once again. Hey, this is an example. I did not type green right. I put an M instead of an N. And you can see here it says, did not understand your input. Please enter again. That was my failsafe at the very end where I wrote down here for an else. So now let me type this green correctly here. Green. Now you see it turn green. Blue. Pretty, isn't it? Cyan. That is pretty much blowing out my little camera there, but it is cyan. Magenta. Ooh, that's pretty, isn't it? Yellow. Hey, orange. There's another nice one. White. Did I miss one? Did I do blue? I think I did, but just in case if I didn't, there's blue again. I did do blue. Okay, and I also added an off. There you go. There's what I did, and like I said at the first, I was going to do what's going to be for lesson number 13, but stick around and see my next one, and you'll see what I was going to do that Paul already asked us to do for an extra bonus one for 13, and my next one, you'll see it. If you have any questions or comments, leave them down below, and I'll do my best to try to return it. Until next time, be safe out there, everyone.